Hello students, in my previous class we dealt some of the topics related to electromagnetic waves and the remaining topics we will deal on today. Here we have the first topic as electromagnetic spectrum. The meaning of electromagnetic spectrum is that the electromagnetic waves are classified according to wavelengths and their frequency and the uses. So, classification of electromagnetic waves according to group of waves with specific applications is said to be as electromagnetic waves. They are classified as follows, which are written in the board. Gamma rays, its wavelength ranges from 10 to the power minus 3 angstrom to 1 angstrom, discovered by Henry Becquerel. Second class of electromagnetic spectrum is X-rays, which ranges from a wavelength of 1 angstrom to 100 angstrom, discovered by Roentgen. Third one is UV rays. Wavelength range of this UV rays is 100 angstrom to 400 nanometer, discovered by Ritter. Next is visible light. Visible light have the wavelengths from 400 nanometer to 700 nanometer, discovered by Newton. And next one is infrared rays, whose wavelengths corresponds to 700 nanometer to 1 millimeter, discovered by William Herschel. Next we have microwaves, whose wavelength range is 1 millimeter to 0.3 meter, discovered by Hertz. Next one is radio waves, having the wavelength range of 0.3 meter to 10 to the power 5 meter, discovered by Marconi. Now we will see the details of all this electromagnetic spectrum. First one is gamma rays. It is discovered by Henry Becquerel. The wavelength corresponding to this one is 1 angstrom to 10 to the power 1 angstrom to 10 angstrom. The frequency range of this gamma rays includes 3 into 10 to the power 18 hertz to 3 into 10 to the power 17 hertz. Now it is produced by nuclear reaction and it is from the nuclear origin. During the fission and fusion reactions or during nuclear disintegration, gamma rays are produced. Properties of gamma rays includes, as its frequency is very high, so its penetrating power is also high and the ionizing power is low. They show fluorescence, phosphorescence, reflection, refraction, polarization, interference and diffraction. Now they are dangerous for human beings. They can be stopped by thick concrete. Now we will see the uses of gamma rays. They are susceptible to kill tumor cells and it is used in some preserving some foodstuffs also. To carry out nuclear reaction also gamma rays are used. Detection. Now we will see the next one is detection. The detection of gamma rays is done by ionization chamber, scintillation counter, Geiger-Müller chamber. So how it is detected? First, a gamma rays is allowed to fall on a material. When gamma rays strikes at the material, electrons emit out. This electron emission is due to Compton collision, Compton effect, and the emitted electron is read by a counter called scintillation counter, which directly depends upon the strength of the gamma rays falling on it. In this way, gamma rays can be detected or determined. Next we will see the X-rays. The wavelength of X-rays corresponds to 10 angstrom to 100 angstrom, discovered by Roentgen. Its frequency ranges from 3 into 10 to the power 17 to 3 into 10 to the power 16. It is produced by two ways. One is inner cell transition of electron, that is when electron jumps from lower orbit to lowermost than that, then this type of rays emits, which is called X-rays. Apart from this, another way is also there by which X-rays can be produced. That one, when fast moving electron is suddenly stopped by a target material of heavy mass, then a radiation emits out. This radiation is in the range of X-ray. So X-rays can also be produced by making a fast moving electron to suddenly stopped by a target of heavy mass. During this process, rays will emit and this rays is said to be as X-rays. It have the property that it will travel with the speed of light. They show fluorescence as well as phosphorescence in certain metals. They affect the photographic plate. Their ionization power is higher than the gamma rays and penetration power is low. They are harmful to human being. It may cause cancer for if it is acts for long time. Uses: it is used to study the tumorous cells, to see internal breakage of the bone, and it is also used to check the prohibited items in luggages. It is also used to find out the cracks in metals and to study the molecular structures with the help of X-ray films. Next we will see the UV radiation. Ultraviolet radiation have the wavelength range of 100 angstrom to 400 nanometer. Its frequency ranges from 300 10 to the power 16 to 7 into 10 to the power 14. Discovered by Ritter. It is produced by passing electric discharge through hydrogen or xenon gas. Suppose that here if we have a gas, then ultraviolet rays is produced by passing electric discharge through this gas. When electric discharge passes through the gas, UV radiation is produced. So, this is the way by which ultraviolet radiation is produced. Another way of producing ultraviolet radiations is by using semiconductor devices. Nowadays, we have several semiconductors which can be used to produce the ultraviolet radiation. Now, we will see the properties. They travel with the speed of light in free space. They show the property of reflection, refraction, polarization, diffraction, interference. They affect the photographic plate and they are harmful for human life also because it will cause skin cancers. Sun is one of the source by which ultraviolet rays is produced. Ozone, which is present in our atmosphere, absorbs this harmful ultraviolet radiation and converts from oxygen O2 to O3. Thereby, it filters the UV radiation and the remaining radiation which is necessary for us is received to the earth surface. So, as we know that it can cause the effect on photographic plate. It shows fluorescence as well as phosphorescence. It kills the germs and it can be stopped by using simple glass plate. Now, we will see the uses of ultraviolet radiation. It is used to study some molecular structures. It is also used to study the invisible fingerprints in forensic laboratory. It is used to check the forged documents and then fake notes. It is also used to kill the germs and in water purifiers. It is again used in LASIK technology, which is one of the technology used to do the surgery of eye. LASIK full form stands for laser assisted in situ keratinoanalysis. So, next we will see the detection. So, the detection of ultraviolet radiation includes a photographic plate, because we saw that a photographic plate is affected by ultraviolet radiations. That is why a photographic plate can be used to check the ultraviolet light, and then quinine coated film can also be used to detect the ultraviolet radiation, because quinine coated film absorbs this ultraviolet radiation and shows the fluorescence. So, fluorescence is the property of a material in which a light of a particular frequency is absorbed, and after absorption of that light it re-emits the radiation. So, using quinine you can check the presence of ultraviolet radiation. It absorbs that ultraviolet radiation and it re-emits the light corresponding to ultraviolet light. In this way, a quinine material or a photographic plate can be used to study the ultraviolet light. Next, we will see the visible light. The wavelength corresponding to visible light includes 400 nanometer to 700 nanometer. Its frequency corresponds to 7 into 10 to the power 14 to 4 into 10 to the power 14, discovered by Newton. Visible light is produced when electron jumps from higher energy level to the orbit of lower energy level, as shown in the figure. If we have electron at the center and if we have orbits, if the electron from the higher orbit energy level when jumps to lower orbit energy level, then radiation emits. The wavelength of this radiation corresponds to visible light. Now, we will see. So, this is the way by which we can produce a visible light. Next, we will see the properties. So, the properties of visible light is that it affects the photographic plate and it gives the sensation of vision. It travels with the speed of light. It shows the property of reflection, refraction, diffraction, interference and polarization. Now we will see the uses of visible light. As I told you that it gives the sensation of vision, and another use is that we can able to see the objects in presence of visible light only. Eye is one of the organism which can detect visible light. Eye contains rod cells as well as cone cell. Cone cell is used to detect the color, whereas rod cell is used to detect the intensity of light. After detection by the cone cells, the color is detected, and after detection it converts into electrical signal which is passed to the brain for processing by optic nerve. In this way eye works and we can able to see the objects present around us. Next we will see the infrared light or infrared radiation. Infrared radiation have the wavelength ranging from 700 nanometer to 1 millimeter. The frequency corresponding to infrared is 4 into 10 to the power 14 to 3 into 10 to the power 11. It is discovered by William Herschel, and it has been divided into 3 categories: middle infrared, near infrared, far infrared. It is produced by vibration of atoms and molecules. So, several devices which is used to produce the infrared radiations are globular tubes, laser light, Nernst lamp which consists of a lamp of zirconium, cesium and thorium. When we heat this filament by passing electric current, a hot radiation is emits out. This hot radiation is called infrared radiations, or it can be produced by hot bodies. The properties of infrared radiations are: it heats up the matter, it affects the photographic plate, it travels with the speed of light, it also shows the property of reflection, refraction and interference. Uses: it is used in military applications, remote sensing, remote controls of TV, VCRs, etc., and it is also used to see the invisible writings, ancient invisible writings on the stones. And night visions camera also it is used. And then some molecular structures also can be studied with the help of infrared radiations. Detection of infrared radiations includes bolometer, thermopiles, thermometers and heat sensors made up of semiconductor devices. Next we will have microwaves. The wavelength corresponding to microwaves are from 1 millimeter to 0.3 meter. Its frequency ranges from 3 into 10 to the power 11 to 10 to the power 9 hertz. Discovered by Hertz, and it can be produced by the controlled flow of electrons in a semiconductor devices. That is, by applying electric field, electrons can be controlled, and when electron controls, radiation or waves is emitted. These waves are said to be as microwaves if it corresponds to wavelength of 1 millimeter to 0.3 meter. Another way of producing microwaves includes vacuum tubes, which contains gun diode, klystron, magnetron. Properties of microwaves are: they travel with the speed of light, they show reflection, refraction, interference, diffraction, polarization, and at the receiving antenna it produces the spark. That is also one of the property of microwaves. And then microwaves is used in satellite communication, mobile communication, radar, cable networks, etc. And detection is done by using point contact diodes. Microwaves are also used in microwave ovens. Microwave ovens contains, when we use the food materials that contains water in a microwave, the frequency of microwaves corresponds to the frequency of vibration of water molecules. As a result of that, the water molecules starts to vibrate. Because of that vibration, internal energy of water molecules increases, and thereby the food cooks whatever we place in a microwave ovens. So, in this way microwaves are used in microwave ovens to cook the foods. Next we will have the radio waves. Radio waves have the wavelengths corresponds to 0.3 meter to 10 to the power 5 meter. Its frequency is ranging from 10 to the power 9 hertz to 3 into 10 to the power 3 hertz. Discovered by Marconi, and it is produced due to the rapid acceleration and deceleration of charged molecules in a conducting wires that we already studied in our previous topics. So, the properties of radio waves includes it travels with the speed of light in free space, it shows the property of reflection, refraction, interference, diffraction, polarization. They produce current when it strikes at the receiving antenna, and it is also used in radio astronomy to receive the extraterrestrial radio waves. It is also used in communication purposes, transmission of voice signals, TV voice communication, radio broadcastings, mobile voice in very high frequency range. It has been divided into amplitude modulated wave, frequency modulated wave, short waves, which are used for communication purposes. Detection of radio waves is done by antenna. When electromagnetic waves strikes at antenna, antenna develops a current, and that current is amplified and fed to the loudspeaker in receiving end. Thereby, message signal can be transferred from broadcasting station to receiving end through the help of radio waves. So, next we have the Hertz experiment. Here I have shown the picture which includes the circuit diagram that is used by Hertz in order to identify the production of electromagnetic waves. The instrument consists of inductor as well as capacitor. Maxwell theoretically gave an idea that electromagnetic waves are emitted due to accelerating charge particle that is produced due to the interaction of oscillating electric as well as oscillating magnetic field. Through his 4 equation he explained. That explanation was experimentally predicted by Hertz experiment. The instrument consists of inductor, capacitor. AC signal is fed to the inductor. Because of this AC voltage, an inductor magnetic energy will be stored. This magnetic energy density is given by half B square by mu. Similarly, when this energy is supplied to capacitor, the energy stored in a capacitor is given by energy density is equal to half epsilon 0 E square. So, both the energies, that is magnetic energy as well as electrical energy, are oscillatory in nature. Because of this oscillatory nature, the electric field which appears across the capacitor plates starts to ionize the gas molecules present across the capacitors. Because of that ionization of the gas molecules, it provides a path for the discharging of charge particle. Due to this discharging of a charge particle starts to oscillate or accelerates, and this accelerating charge particle produces electromagnetic waves. The gap between capacitor endpoints can be adjusted by using spheres, and then this electromagnetic waves is received by a detector. A detector is placed at some distance, and at some distance the detector contains 2 terminals. When the electromagnetic waves strikes at these 2 terminals, a spark is produced across the detector. This indicates that the electromagnetic waves can travel in a space. Now, it is also confirmed the transverse nature of electromagnetic waves, that is, a detector once placed in horizontal plane, when it is placed in horizontal plane, no such type of spark has been noticed. When it is placed in a vertical plane, a spark is seen between the points S1 and S2. This indicates that electromagnetic waves are transverse in nature. The frequency of these electromagnetic waves is determined by the inductance as well as capacitance value. So, here we have F is equal to 1 by 2 pi under root L C. So, taking the known value of inductor and the known value of capacitance value, frequency is determined, and the same frequency has been examined through the process of reflection. So, for the case of reflection, what the Hertz did, he took the electromagnetic waves and he allowed to fall on some target material, and then he made that electromagnetic waves to reflect from the target, and when it reflects, it superimposes with each other. When this superimposes, when the 2 waves, that is incident wave and the reflected wave, superimposes with each other, we get a standing wave. So, from the theory of standing waves, the frequency is determined and it is observed that the frequency of these waves appears to be same as the frequency of LC components. So, this implies that electromagnetic waves produces by LC circuits, at the same time it also propagates in a free space with some speed of light. Next we will see the greenhouse effect. So, greenhouse effect means that the infrared part of the sunlight which falls on the surface of the earth, that is, if we have earth, here suppose that sun is there, sun contains three rays, that includes infrared, visible, ultraviolet. Ultraviolet radiation is absorbed by the outer atmosphere, which consists of oxygen molecules. These oxygen molecules on absorption, it converts to O3 ozone layers. In this way, ultraviolet radiation is stopped by the outer atmosphere, whereas visible light as well as infrared enters through the atmosphere. Let us suppose that infrared rays got entered into the atmosphere. Here the molecules such as CO2, whatever present in our atmosphere, absorbs the infrared radiation, and thereby it blocks that radiation, blocks that infrared radiation to pass from the atmosphere to outward. As a result of that, the infrared radiation get traps and it will reflect within the atmosphere and it warms the atmosphere. So, this effect is said to be as greenhouse effect, and it will be very beneficial for the plants. So, greenhouse effect is used for to make the survival of plants during the winter season. So, greenhouse, I mean the plants which are present, this plant, the outer surface of the plant is covered by polythene paper. Here let us suppose that some plants are there. When infrared radiation enters into the polythene paper or plastic transparent paper, allows the infrared passes through this transparent plate, and the carbon dioxide molecules absorbs this infrared radiation and keeps warm up the atmosphere present inside of the transparent polythenes. So, this fact is used in winter season to keep the plants warm. This effect is said to be as greenhouse effect. We completed the chapter. Now we will do some of the numericals. Here we have a first numerical on your screen. The electric field in an electromagnetic wave is given by E equal to 60 sin omega under bracket T minus x by C. Now we have to calculate first the energy contained in the cylinder of cross sectional area 5 centimeter square and length 80 centimeter along x axis. Second, we have to calculate the intensity of the wave. So, let us see this numerical. Here the given parts are electric field is given E equal to E0, electric field E equal to 60 Newton per coulomb sin omega T minus x by C. Now, area of cross sectional area is given, A is equal to 5 centimeter square. We know that 1 centimeter is equal to 10 to the power minus 2. So, this can be written as 10 to the power minus 2 whole square. This gives 5 into 10 to the power minus 4 meter square. So, area of cylinder is given 5 centimeter square. After conversion comes out to be 5 into 10 to the power minus 4 meter square. Next, length of the cylinder L is given. L is equal to 80 centimeter. 80 centimeter, which is equal to 80 multiplied by 10 to the power minus 2 meter. We are asked to find out first portion, energy E is equal to question mark, energy is equal to question mark. So, when we compare this equation with the general equation of electric field of electromagnetic waves, we get E is equal to E0 sin omega t minus kx. Here we have, on rearranging the equation, you get E equal to 60 Newton per coulomb sin omega t minus omega x by c. So, here when we compare these two equations, we get E0 is equal to 60 and omega by c is equal to k. where omega is angular velocity, c is speed of light. And we have to find out the energy. We know the formula that is related to electric field, which is given by energy density. Energy density is equal to epsilon 0 of epsilon 0 E square. So, energy density means energy per unit volume. This is equal to half epsilon 0 E square. So, energy that corresponds to given cylinder of area of cross section as well as length is given by U equal to 1 by 2 epsilon 0 E square multiplied by V, where V is volume and it can be written as area multiplied by length, and this will be equal to half multiplied by epsilon 0 E square multiplied by A multiplied by L. Now, the value of epsilon 0, we know that it is 8.85 into 10 to the power minus 12. So, we can put that value here. You get 8.85 into 10 to the power minus 12 multiplied by the value of electric field is 60. So, it is 60 whole square multiplied by area of cross section is given 5 into 10 to the power minus 4 and length is 80 into 10 to the power minus 2. Further, this can be written as, so with 2 80 can be cancelled, you get 40. So, this is further can be written as 8.85 10 to the power minus 12 multiplied by 36 into 10 to the power 2 into 5 into 10 to the power minus 4 into 40 into 10 to the power minus 2. So, 8.85 can be approximated as 9 into 36 into 5 into 40 into 10 to the power minus 12 plus 2 minus 2 minus 4. So, solution of this simplification of this one is comes out to be 6.37 into 10 to the power minus 12 joule. So, in this way we calculated the energy that is contained in a cylinder. Next we are asked to find out the intensity. Next we will try to find out the intensity. The formula for intensity is energy per unit area per unit time, and we have the energy density formula is given by U by V is equal to half epsilon 0 E square, where E is electric field and epsilon 0 is the permittivity of a space. Now, volume can be written as A multiplied by L. So, U divided by A equal to L has been brought towards the right side. So, as shown in the equation next, with T has been multiplied on the denominator of both right hand side and left hand side, you get U divided by A multiplied by T. So, U divided by A multiplied by T is nothing but it is intensity. Therefore, intensity comes out to be half epsilon 0 E square L by T is C, where C is speed of light. Now, we will substitute the values of E, C as well as epsilon 0 to get the value of intensity. So, intensity I is equal to half multiplied by epsilon 0 is 8.85 into 10 to the power minus 12 multiplied by the value of E we already have, it is 60 multiplied by, of course it is 60 square multiplied by C, which is 3 into 10 to the power 8. So, after this you have half multiplied by 8.85 into 10 to the power minus 12 multiplied by 60 into 3 into 10 to the power 8. With 2 this 60 can be cancelled, you get 30. So, finally you have 8.85 into 30 into 60 into 3 into 10 to the power 8 into 10 to the power minus 12. Further, this can be approximated as 9 into 3 into 6 into 10 to the power 2 into 3 into 10 to the power 8 minus 12 is minus 4. So, this can be 9 into 3 into 6 into 3 into 10 to the power minus 2. Simplification of this one gives 77 watt per meter square. So, in this question we calculated the energy contained in a cross sectional cylindrical area. Here we have cylinder, through this cylinder electromagnetic waves are passing. So, we calculated the energy that is contained in this cylinder and the intensity that is received by this cylinder in a given area in given time. So, these are the few topics we touched in this chapter, and I hope that you all will practice at home, and in our next class we will deal the next chapter. Till then, practice all the questions. Thank you.